Hi, today we're talking about percent error. And I'm just going to go ahead and start with reading the definition, which says that accuracy is the degree to which an estimate or measurement agrees with an accepted or actual value of that measurement. So if you, let's say you got 100% on the test, you're 100% accurate. If you got an 85, then you were 85% accurate, and then 15% inaccurate. So they're saying you can describe accuracy with a measure called percent error. So we have these two words here, accuracy and percent error. So I'm just going to bring up this scenario to you. Let's say that if my dog is supposed to eat 1 cup of food a day, and I use a plastic cup with no measurement, when I actually dump the food from a plastic cup into a measuring cup, it measures less than a cup. So the amount that I am short is my inaccuracy or my percent error. Because if let's say that it was 3/4 of a cup, I was accurate by 3/4 of a cup, and I'm inaccurate by 1/4 of a cup. So that would make my percent error 25%. And we'll go over that. Hopefully I just gave the right answer. So we are going to be solving these the exact same way that we were solving our other percent problems the other day. That we're going to continue to use a proportion where you've got the percent of error divided by 100 equal to the amount of error divided by the actual amount. And this is extremely similar to when we talked about amount of change or amount of decrease or increase, where you also could solve the problem where you say the amount of error divided by the actual, and then figure out that answer as a decimal, and then multiply that decimal by 100, and that would also give you the percent. You really end up doing the same amount of work either way, so one's not really better than the other. So for question number 1, they're asking us to find the percent error of each estimated value to the nearest whole percent, and they're asking us to show our work. So if I look back and I'm using my proportion, this is my percent error. I like to label on my proportion so I can keep track of my information. That's my percent error. So since, again, there's an equal sign here, directly across from that must go the amount of error. We're looking for the percent error. And the actual value always go on the bottom, because I'm trying to compare my error to what the real amount is. So I put 45 on the bottom. So the estimated value says it's 40, so that would mean that my amount of error would be 40 minus 45 or 45 minus 40. We're just talking about the distance that our error is, so it doesn't matter if it's positive or negative here. So my amount of error is 5. So then I would go 45 times n equals 500, divide both sides by 45, and get 11%. So my percent error would be 11%. Okay, I'll move that up a little bit so it's easier to see. Same thing here. I'm going to do the percent error divided by 100. My actual value goes on the bottom. Again, the amount of error is the difference between 63 and 75, or 75 and 63. Since we're talking about distance again, you would get a positive answer no matter what, because distance is positive. And so the amount of error here is going to be 12. Since there's no whole number to take me from 100 to 75, I'm going to again do my cross multiplication. So we'll have 75n equals 1200. Divide both sides by 75. And I will get 16%. And what I really like about doing the proportion is that if I put my labels and I say that this is the percent error, then I will remind myself that I need to have the amount of error here. Because really all you're doing is using the same exact description, except for on the left side I'm saying percent, and on the right side I'm saying amount. So go ahead and give C a try. So on this one, I have n divided by 100 equals 26 divided by 99. 99n equals 2600. Divide both sides by 99, and I will get approximately 26% because they asked me to round to the nearest whole percent. So this will be 16%, this will be 26%. And up here it asks me to go to the nearest whole percent. So go ahead and give number 2 a try. Okay, so for this one, I got an answer of 25%. And after I went through and did my cross multiplication, I realized, well, to go from 100 to 200, you also could multiply by 2, which means what times 2 will give me 50? 50 divided by 2 is 25, so you also get 25%. Okay, moving on to the back, they're talking about this jar of jelly beans, and anyone who guesses within 5% of the actual number of jelly beans in a jar is a winner. So that means that they could go above or below the 486 jelly beans in the jar, just as long as they're within 5%. So we want to know who's going to win and who's going to lose. So to show our work again, we want to remind ourselves that we're doing percent error. So the amount of error is what I need on the other side. So I had to find how much error Sarah had compared to the 486, which will give me 98. And the actual amount is 486. So again, what you could do here if you wanted to is you could take and do 98 divided by 486 and get a decimal of 2/10 and then multiply that decimal times 100 to get our answer of 20. Or we could go through and do our cross multiplication, but either way, you're going to get the same answer. So if you just wanted to change this to a decimal of 0.2016, and I like to always put a couple place values there in case I have to round, then I would take that and again multiply it by 100 to get approximately 20% for my answer. So Sarah is not within 20%, so sorry, Sarah, you're going in the loser column. Javier, he said 501, so 486 minus 501 is going to give us 15. And so again, I'm going to be doing 15 divided by 486. Give me approximately 308 10,000ths, which I then multiply by 100 to get me approximately 3%. So it looks like Javier gets to be a winner. Go ahead and try the next two. And on this one, I got that Lisa was at 2%, Jay was at 7%. So Lisa is a winner as well, and Jay is a loser. Sorry, guys. Next, for question number 4, they're saying that a weatherman predicted 17 inches of snow, and the town actually got 1.5 feet of snow. By what percent was the weatherman's prediction off? We need to make sure that we have both of our answers in the same units in order to be able to compare them by multiplying or dividing. So you either can change 17 inches to feet or convert 1.5 feet to inches. 1.5 feet, well, 1 foot is 12 inches, a half a foot is 6 inches, so 12 inches plus 6 inches will give me 18 inches. So, again, percent error, amount of error, that's the key that we need to remember to subtract, and the actual. Well, he predicted 17, the actual that they got was 18, they were off by 1 inch, and so what would the percent of error be? So I would do 18 times n equals 100, divide both sides by 18, do 100 divided by 18, and I get approximately 6%. Okay. On the next page, now we are looking at a dot plot. And if you guys remember these from previous years, a dot plot shows how many times something occurs. So at 1 2/10, somebody measured that 4 times. At 1 3/10, somebody measured that 2 times. So this dot plot shows the measurement made by a science class. If the rock's actual mass is 1 1/10, what is the greatest percent error among the measurements? And round your answer to the nearest tenth of a percent. So be careful with the rounding there. You have to first change it to a percent before you can actually round it. So they're telling us that the 1 1/10 is the actual amount. And they want to know what is the greatest percent error. So they want to know who had the greatest error. Well, if you try to think about evenly distributed here, 1 3/10 is 2/10 away from 1 1/10. 8/10 is 3/10 away from 1 1/10. So this one has the greatest error. Who had the least error? All the people that had the actual amount. They had 0% error because they were 100% accurate. So they had 0% error. They were the least amount. So that's how we're going to set up our proportion. Our greatest error is 8/10 minus the 1 1/10 to give us 3/10. The actual amount is the 1 1/10. And again, I'm looking for the percentage here. So 1 1/10 times n equals 3/10 times 100, which will be 30. Divide that by 1 1/10. We should get an answer of approximately 27, and then it keeps going 27%. Rounding that to the nearest tenth, I look at that number in the tenths place, and that 7 makes the 2 go up. So we're looking at 27 3/10%. Okay. Question number 6. Go ahead and give that one a try on your own. So this one says that if the rock's actual mass is 5 9/10, this time here is our actual. They want to know what is the greatest percent error among the measurements. So be careful. If there is not a dot above one of the numbers, then nobody measured the rock to be that value. So you can't go over to 4 9/10 and say that, oh, that's far away from 5 9/10 too. We have to look at who was the most wrong. And that would be this person at 7 3/10. This is the greatest error. So again, I'm going to be putting n divided by 100. The amount of error is 7 3/10 minus 5 9/10, which is 1 4/10, divided by the 5 9/10. So that gives me 5 9/10 times n equals 1 4/10 times 100. So the decimal is going to go 2 places, so it'll give me 140. Divide by 5 9/10. They want me to round to the nearest tenth of a percent again. So I'm looking at 23 7/10%. For the last one, number 7, it says that the dot plot shows the measurements made by a science class. If the rock's actual mass is 5 9/10 grams, what is the least percent error among the measurements? Round to the nearest tenth of a percent. Well, the actual is 5 9/10, which means there were a number of people that were actually correct. So instead of saying greatest percent error, they're now saying the least percent error. So who was the closest? Well, all of these people did actually say 5 9/10, so this would be a 0% error. That means that those people were 100% accurate. Okay? Thanks for watching, guys. If you have any questions, be sure to ask in class. Have a great night.